Welcome to Simply Pi Maths.
Arithmetic progression. So let's understand what this arithmetic progression mean. So if I give you some numbers like 2, 4, 6, 8 and so on, and if I ask you whether this sequence of number is an arithmetic progression or not, so simply what you have to do is you have to look at the difference between any two numbers. So let's say if I ask you what is the difference between 4 and 2, it is 2, right? Even if you see the difference between the next two numbers, it is the same. So 6 and 8, it is again 2. You can take any two numbers. You can take these two numbers as well, the numbers in between. So the difference between them is also 2. So if you see, the difference between all the two numbers are 2. So such sequence is called as a arithmetic progression. Basically, it means if the difference between any two numbers comes out to be the same, then we can call such a sequence as arithmetic progression. Just to give another example, let me just take 5, 10, 15, 20 and so on. Can you tell me, is this arithmetic progression? Yes. Why so? If you take any two numbers over here, you will see a difference as 5, isn't it? So difference between 20 and 15 is 5. Difference between 10 and 5 is also 5. Difference between these two middle numbers is also 5. So this time all the differences are 5, that is same. That means this sequence is an arithmetic progression. Okay. So in arithmetic progression there are two terms. One is A and the other one is D. So let's understand what is this A and D at the first place. So A means in this sequence whatever the first number is, right? This is called as A. So in this case, the A is nothing else but 2. And whatever difference you see between the two numbers, let's say in this case we have 2 everywhere. So that difference is nothing else but D. So to be more precise, it's not just a difference, it's a common difference. Why so? Why we use the word common difference? Because if you see, it is common everywhere, right? If you see the second example, if I ask you what is A in this, A is the very first term. So in this case it is 5. So it should be 5. And if I ask you what is the common difference here, so common difference is again like common differences are the same. So it is also 5. Okay. So this was the very basic concept of arithmetic progression. And now let's look into few more terms. So if I ask you what is this first term, so this is called as A. This A is also the very first term is called as A, that is fine. But this term is also termed as T1. T1 means first term. So obviously what will be the second term called as T2? What will be the third term called as T3? What will be the fourth term called as T4? If at all we had one more number over here, it would have been called as T5, then T6 and so on. Okay, so let's keep these basic concepts in our mind and let's start with our sum. So let's look into the very first sum. So it asks a question saying that which of the following sequence is an AP? So the same thing, 2, 4, 6, 8. So we knew that it is an AP. Now let's see how to represent this as a solution. So at the very first place, you will term the first term as T1. T1 is 2 here. T2 is 4. What is the third term? T3. T3 is 6. Then fourth term T4. T4 is 8. Fine. I just termed each of the terms over here as T1, T2, T3 and T4. Then we need to take a difference of all the two numbers. So let's start like this. Let's take a difference of these two numbers first. That means T2 and T1. So I will say T2 minus T1. So make a note, whenever you're taking a difference, it should be always next number minus previous number. You should not do like T1 minus T2. In order to see whether the difference are same or not, the pattern is next minus previous. So if I take these two numbers, I should take T2 first and then T1. So if I do a subtraction, 4 minus 2, it should give me 2. isn't it? Now let's take the next two pair. So here if I take these two numbers, what should I write the first? This one, then this one. So T3 minus T2. So in this case 6 minus 4, so that will give me again 2. And finally we have one more pair at the end. Let's take these two also. So here also first we'll write this and then we'll write this, next minus previous. So T4 minus T3. So in this case it is 8 minus 6. So what is 8 minus 6? It is again 2. So can you see the difference is same everywhere? 2, 2, 2. So this can be called as an AP, right? So let's write two more lines to finalize our answer. So we'll say here the difference is constant, therefore it is an AP. Done. Simple as that. Okay, so if at all it adds a question over here saying that then find common difference. If anyone asks you to find a common difference in such scenario, so what will be the common difference? So what is the same difference that you can see everywhere? It is 2. So you will add on a line saying that in this case the common difference, that is D, is nothing else but 2. Okay, now let's proceed to the next sum. So the next sum is something like this: 2, 5 upon 2, 3 and 7 upon 2 and dot dot dot. Let's use the same pattern over here. So we'll say first of all T1 is 2, T2 is 5 upon 2, T3 is 3 and T4 is 7 upon 2. And what's the next step? We have to do a difference of all the two numbers, isn't it? So first I will take a difference of these two numbers. So I will do T2 minus T1. So it should be 5 upon 2 minus 2. So what is 5 upon 2 minus 2? How do you do a difference of such a fraction and a normal number? So the easiest way is do a cross multiplication, isn't it? So this 5 will remain as it is. This 2 and this 2 will get multiplied to give you 4. Minus sign will remain in between. In denominator you have to just place this 2. So 5 minus 4 is 1, 1 upon 2. So the first difference gave me 1 upon 2. Let me jump into the next two numbers, T3 and T2. So I will just write here T3 minus T2. So that means 3 and 5 upon 2, correct? 3 minus 5 upon 2. So the same thing over here. Here this time 2 lies over here, right? So this into this, that is 6 minus 5 upon 2. So 6 minus 5 is 1 upon 2. It again give me 1 upon 2. Now there is one more last pair left, T4 and T3. Can you give it a try once? What is T4 minus T3? Let me do it over here, somewhere over here, so that I don't have to jump onto the next page. So I will write here T4 minus T3, T4 minus T3. That means T4 and T3 is 7 upon 2 and 3, right? 7 upon 2, 7 upon 2 minus 3. So what will happen here? 2 3s are 6, right? So it should become 7 minus 6 upon 2. 7 minus 6 is 1, 1 upon 2. So if you see, all the differences are same again. So how you will wrap up your answer? You will simply say the same thing. Here the difference is constant, therefore it is an AP. And if I ask you what is D in this case, so if you see what is a common difference everywhere, it is 1 upon 2. So you will end up the answer saying that here the difference is constant, therefore it is an AP. And finally, what is D in this case? What is a common difference everywhere? It is 1 upon 2. Simple as that. Let's see another example. So this time the sequence is 0.3, 0.33, 0.333 and that's it, dot dot dot. So let's see how to tackle this sum. So how you will find the solution for this, whether it is an AP or not. So at the very first place, just number it, let's name it like T1, T2, T3. T1 is 0.3, T2 is 0.33, T3 is 0.333. This time we don't have 4 numbers, so it is fine, like only 3 numbers are there. Okay, so let's proceed with it. So first of all, the difference of first 2 numbers, so I will do a T2 minus T1, and then what, T3 and T2, I will do a T3 minus T2. This time I don't have a 4th number. If I had, I would have wrote like T4 minus T3. So since there are only 3 numbers given with us over here in this sequence, we know like the next number might be 0.3333, like 4 times 3, but that is not required. Whatever is given to you, you just pick them up and do a difference of all the 2 numbers. Just make a note that you should always do next number minus previous number, next number minus previous number. Now let's see what is the answer for this. What is T2 minus T1? That means 0.33 minus 0.3. And what is T3 minus T2? That means 0.333 minus 0.33. So now let's understand how to do a subtraction of decimal numbers at the first place. So whenever you have 2 decimal numbers and if you have to subtract them, make sure that you are doing it like this. So what I'm doing over here is, I'm just keeping the 2 decimals of the decimal of this number over here, decimal of this number over here, and the decimal of the answer over here. Means what? All the decimals should be on the same line. That should be the very first thing that you have to make a note of. Now let's go on writing the number. It is 0.33. So I will write 0.33. Next is 0.3, 0.3. And I have to do a subtraction. So if you see, there is nothing below this, right? So you can give a 0 over here. So this is an additional 0 that I'm adding because there is no number below this. So 3 minus 0 is 3. 3 minus 3 is 0. 0 minus 0 is 0. So what's the answer for this? 0.03. Now let's do a subtraction of these 2 numbers now. So it is 0.333, right? The same way, the same approach we'll use again. So this time what? Again, we have 2 decimal numbers. So let's make sure that the decimals are on the same line. And then let's start writing the numbers. 0.333. Then the next number is 0.33. Here, this time, here one number is missing, isn't it? So let's put a 0 over there and let's start writing the answer. 3 minus 0 is 3. 3 minus 3 is 0. 3 minus 3 is 0. 0 minus 0 is 0. So 0.003 is the answer. So do you see both answers are same? No, right? Both are different. So this time what you will say here, the difference is not constant. If it is not constant, then what? Therefore it is not an AP. Make a note, if it is not an AP, you will not be able to write the answer for D also, right? Why so? Because there is no common difference. All are different, right? So you cannot write an answer for D. So you should end up your answer saying that it is not an AP. That's it. Now let's see somewhere it contains some roots inside it, like 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2. Let's see what happens in this. The same thing we'll have to say. Solution. First of all, the first number should be T1. Let me write T1 is 3. Next, just have a note. So this is your first term. This complete thing is your second term. This is your third term, and this one is your fourth term. Okay. So T1 is this, and then next one is T2. T2 is 3 plus root 2. Then T3 is 3 plus 2 root 2. Then finally T4 is 3 plus 3 root 2. Okay, fine. Now let's start subtracting all the 2 numbers, right? So I will do a T2 minus T1 first, then T3 minus T2, then I have 4th number here this time, so T4 minus T3. Let's see, all the three gives me the same answer or different. So first of all, t2 minus t1, isn't it? So I will do a subtraction of 3 plus root 2. I will just write this number first. Then what? The next number 3 over here, 3. And then what I need to do? A subtraction. Okay, so simple as that. What we did is, first I wrote this one, then I wrote this one, then I put a subtraction in between. So if you look at this, in this entire line, you see a 3 over here, you see a 3 over here. So just ignore this root 2 for time being. Just look at this, 3 minus 3. What is it? 0, isn't it? 0 means what? This will get cancelled off. So what's left with you? Just root 2. So the answer is root 2. It was that simple, right? Now let's look into the next two pairs, t3 and t2. That means this and this. Okay, this time it will be a bit different. Let's see how to tackle this. So first of all, I will write t3, that is 3 plus 2 root 2. Then I will write this guy, that is 3 plus root 2. Then I will put a subtraction. This time make a note of this. So when I put a subtraction sign over here, after that, it is not just one term. There are two terms over here. So it is mandatory that you should put a bracket. Okay. Why so? Because now a line will get added over here where you will be opening up the bracket. That means this will remain as it is. Means the terms before brackets will remain as it is. The terms after bracket, right? So there will be a small difference happening over here. Because of this minus sign, this plus will become minus. So it should be something like 3 minus root 2. Okay, so this was a bit tricky one. So let's see what will happen the next. So yeah, in this complete line, just do the same thing that we did before. So if you look at into this complete line, you see a 3, a minus 3. 3 minus 3 means what? It will become 0. Just ignore them. Okay, I will just erase it like this. So don't look at these two things now because they are getting cancelled. Now just focus on 2 root 2 minus root 2. It is just like saying, 2a minus a. What is 2a minus a? A, right? So similarly, if I ask you 2 root 2 minus root 2. So just think that this root 2 is nothing else but an alphabet, okay? Don't think like a root 2. Rather, just treat it as an alphabet. If I ask you 2a minus a, you will say a. If I ask you 2b minus b, you will say b. So if I ask you 2 root 2 minus root 2, what should be the answer? 2 root 2 minus root 2. It should be, as 2b minus b is giving me b, 2a minus a is giving me a, 2 root 2 minus root 2 will give me root 2. Okay, so the answer over here is root 2. Let's look into the last pair now. We have one more pair, right? So t4 and t3. t4 is this, t3 is this. Let me just write this first, 3 plus 3 root 2. Then let me write this one, 3 plus 2 root 2. And let me put a minus over here. So when I put a minus, there are two terms over here, so I should put a bracket again. The same thing will repeat almost. The first two terms will remain the same. Then I will put a minus. Then I will open up this bracket, due to which what will happen? This will become a minus 2 root 2. So the same thing, 3 minus 3 will get cancelled off. So this time what do I have remaining? 3 root 2 minus 2 root 2. So 3 root 2 minus 2 root 2 is 1 root 2, isn't it? So I will just write root 2. So do you see the difference same this time? Yes, the difference are same. So what you will say here? Here, the difference is constant, therefore it is an AP. Moreover, if I ask you what is the common difference in this case, so common difference is root 2, isn't it? Everywhere it is root 2. So common difference, that is D, is root 2. Let's see one more example. So this time let's take some negative numbers. Let's play around with some negative numbers like minus 10, minus 6, minus 2, 2, and so on. The activity will remain the same. You will write a solution first of all, and then you will start with t1, which is minus 10, then t2, which is minus 6, then t3, which is minus 2, and t4, which is 2. After that, you will do a subtraction of all the two numbers, isn't it? So this time it will be like t2 minus t1, then t2 minus t1, then t3 minus t2, t3 minus t2, then t4 minus t3, t4 minus t3, and here we go. t2 minus t1, t2 means it is minus 6, t1 is minus 10. Then what I need to do with these two numbers, I need to do a subtraction, isn't it? So if you see the way that I have written, first I wrote t2, then I wrote t1, then I added a subtraction sign in between. Now I see two subtraction sign one after the other, so I will put a bracket over here. So obviously the next step will be to open up the bracket. So when I open up the bracket, what will this happen? Minus minus will become plus and 10. Let's try to find the answer for this. How will you do that? Plus minus is minus, so do a subtraction of these two numbers, that will give you 4, and then bigger numbers sign, that is plus. Plus we don't write usually. Then t3 and t2, so what you will do, t3 is minus 2, I just wrote it. t2 is minus 6, I wrote it, and I will put a subtraction sign in between. Since minus are coming one after the other, I will put a bracket, and in next line I will just open it up. That means I will make this plus and 6. The same thing, plus minus minus, if you subtract them it will give you 4, and sign of the bigger number, it's addition, plus, so we don't have to put that. And finally last two pairs, so that means this time it is t4 is 2, t3 is minus 2, then subtract them, put a bracket, it will become plus this time, and 2 plus 2 is simply 4. So these differences are the same, right? 4 4 4. So you will say here the difference is constant, here the difference is constant, therefore it is an AP. And moreover, if I want to find the D, I will say the common difference, D is 4.